Hello folks, welcome to 2020. I actually did something pretty crazy over the holidays in that I took a few days off. I know, right? Crazy. But it had a pretty positive outcome, I think, because I got my brain working, which is, a tricky thing to do even under the best of circumstances. And got what I'm hoping is going to be a pretty exciting announcement for you. So for those of you that don't really wish to wade through a 30 or 40 minute video of me detailing all of this stuff, I'll cut straight to the chase so that you can go and watch some funny cat videos. Biggest problem that I've been facing over the time that I've been designing circuit boards and solutions for various EV components like Tesla, Toyota stuff has been getting the boards made. Now I can get the bare boards, no problem, but I have struggled quite a bit with getting them populated so that I can sell them and make them available. So the real point of this video is going to be telling you that I now believe that I have that problem solved, and that over the next few weeks we are going to be able to start selling not just the stuff that I have sold before, like the Tesla Drive unit boards, but more stuff which I think will even be more useful to people, like boards such as this one for running the Toyota Prius and Lexus and various other low-cost inverters. So that is what we're going to be talking to you about. I'm going to go into quite a bit of detail on this. I'm going to show you the process and what I'm doing and how it all works, because I do believe in the principle of I guess open source, and this is how it all works and you can do it yourself. So alright, we're going to be getting into some screen capture stuff here on the old desktop PC, but before we do, obviously it's time to take a quick tour of my high-tech design studio here. So starting off here, for those less critical tasks, we have our old reliable V48K Sinclair ZX Spectrum. Moving up the way for those more challenging operations, we have the Commodore 64 complete with recently purchased 1541-2 5¼ inch disk drive. Additionally, we have the Commodore 1230 printer so that we can print out all of our fascinating designs. And of course, in order to display all of that stuff, we have the classic Commodore 1084 color CRT monitor. So, as they tend to say on videos these days, let's get started. So we're going to jump straight in here and I'm going to show you some, it's going to be mostly screen capture stuff on the whole design and how we make the bills of materials and where we're going to get the boards made, and show you the process for all of that stuff. So let's get into that, and enough of my shiny head. Okay, so first of all, welcome to our PCB CAD program. Now, for those of you that may not be electronically inclined and haven't really done this kind of stuff in the past, what you are looking at here is, I suppose in simple terms, it is a computer aided design package that basically enables one to start off with inputting a circuit diagram for a particular design that we would like to make into a printed circuit board in the real world and have it do something for us. Translate that into a PCB design and output the design files that would be needed then to get the board made physically. So just getting all of the tracks laid out on the board with a manufacturing process, and then to furthermore then to realize how we can actually place the components on the circuit board so that the board actually works. We can put electricity in here and it'll do stuff for us. So that's my horribly brief short version of what we have here, what this particular program, which is called DesignSpark PCB, actually does for us. Now, this is not the only package. There are several of them out there. Probably the most well-known one would be called KiCad, and it's one that I wish that I had some more knowledge of. I use DesignSpark for a few reasons, and I'll just touch on this briefly here because it is a question that I get asked, and people, say to me, well, why don't you use KiCad, or why don't you use, some, other design package. Now, my primary reason for using DesignSpark, or well, I suppose there's a few of them, come from the fact that when I entered industry, well, over 20 years ago now, this kind of stuff was really not that well developed, but there was a company called Number One Systems had a package out called EasyPC, and I learned how to do circuit design and stuff like that with EasyPC. And as the years went on, then I built up libraries and I built up knowledge of how to use it. And later then, DesignSpark came along, which is basically EasyPC, just with a different badge on it. Now, a couple of other things that I'll touch on is it is completely free. There's no restrictions on this. You don't have to pay anything to anyone. It is also completely unrestricted in the number of components you can have, the number of layers you can have, the size of the board, etc. There's a lot of packages out there that are very, very expensive, and they charge more and more for when you want to do more and more with your design, which is fine, but obviously I'm not in a position to start paying out thousands or whatever for design software. So the fact that I was familiar with EasyPC led me into DesignSpark, and that's what I use. Maybe at some point when I retire, I'll get to learn how to use KiCad or something like that. So anyway, very short version there of what this is and why we use this particular iteration of PCB-CAD. Now, what we're looking at here is a PCB layout for a board I did. Actually, when did I do it is the next question. I did it last year, 2019. And this board was designed as a replacement board for the logic control board in the Toyota Prius Gen 3 inverter. Now, background to this is that we're using the open inverter system here designed by Johannes Hubner in Germany. You'll see here the STM32F103 microcontroller is the heart of the whole system, and that's what we've used in a whole plethora now of board designs for Tesla, Toyota, Nissan Leaf, all kinds of things. So it's getting into quite a few things now. It is a fully open source design in terms of both hardware and software. So, in fact, I would encourage anyone that wants a bit more knowledge about this that I can't really give in this video to have a look at the openinverter.org forum. So, back to the PCB design here. I did this, and obviously then I've got to get some bare PCBs made. Now, making bare PCBs these days is not what it was back in the day with photoresist and laying out tracks by hand and all that kind of thing. And the price point for all of this has completely dropped down to the point that a board like this is a 4-layer board. It's about 6 inches square. These will probably run you about anything from 10 to 15 euros per bare PCB, which is just amazing. You can even get them cheaper than that if you're prepared to wait. So I used to use a crowd called Seeed Studio. If you just look up on Google, you'll find them. These are just one of many Chinese companies out there now that will basically take the design files of your design, and so if we went here to add Gerber files, where am I going here? I want to go to Prius, Gen 3, design, plots. So basically, any of these guys work pretty much the same. You basically upload your design, you put the board layers in here. Sometimes they pick it up, sometimes they don't. You have to put the board size in, something like this. But you'll see here, pretty quickly that 10 boards here is going to cost me $157, plus there'll be a bit of shipping and so forth. So it's pretty good for getting bare PCBs and things like that from. So I used to get bare boards from these guys all the time. Now, when it came then to getting them populated, well, I had pretty much got two choices here. I could either do it myself, or there's a company here in Ireland that I have used to populate the PCBs. Now, when I got this design done, I think it was either 3 or 4 prototypes made, and they populated, I'd say, about 95% of the parts. So some of them I didn't have at the time to give them or something like that. But they populated the boards, but they populated them by hand, so it's expensive. I think I had them on my web shop for something like 350 euros, and I think it was costing me more than that to actually get the boards built. So I couldn't really sustain that, and I've been kind of looking at what I could do for alternative ways to particularly get this board made in such a way that people could actually either build them for themselves, or they could buy them from me in such a way that they weren't costing a fortune, and I could make a couple of bucks as well. Now that's been a struggle not only for the Prius stuff, but going into the Tesla side of things as well, and we'll touch on that later. So there are a few crowds out there that offer PCB assembly service. So if we go back and we look at Seeed Studio here, for example, do have PCB assembly service, I think, if I remember correctly. Yeah, they do here. They have a PCB assembly service. Now, I went away from using Seed Studio and I went to these guys, JLC PCB, for getting my bare boards from. Now, I should point out, just in case anyone thinks that I'm getting, some kind of sponsorship gig here, there is absolutely no sponsorship going on here at all. I pay all these guys. I don't have any deals with them or anything like that. So what you're kind of getting here from me now today with this will be a completely untainted review. Now these guys, I found them actually because I watched, believe it or not, some of the channels that I watch on YouTube actually get sponsored by JLC PCB. So I took a look at these guys, signed up an account with them, and if we do the same thing here now, if we bang the Gerber files for our Prius board in here, one more time, get in there. So very similar to Seed Studio, kind of a similar kind of thing, but for some reason they don't pick it up as a 4-layer board, so you have to tell them that. And then we'll say that we want 10 boards. Now you'll see straight away here, if we look at the price, we see that 10 boards from these guys is actually, not a bad price at all. So with the shipping and the VAT and that, you can kind of double that figure a little bit. So they probably work out about 10 euros each by the time they're actually here. I'll go through the process with this even. I'll show you later on maybe. But anyway, and you can do things here like this, like you can change the solder mask to black. I usually like the black solder mask for some reason. I don't know, I just like it. But anyway, so you can get your bare boards from the likes of these guys, and they're very good. They take about a week and a half to get here. They ship with DHL. Any of the boards that I've gotten from them have been extremely good quality. Never had a problem. They actually make them the way I've designed them, whether that's right or wrong. So these guys, JLC PCB, have been my kind of go-to crowd now for getting the bare PCBs that I sell on the web shop and elsewhere, and that I use from my own designs and development and so forth. So, okay, what has this got to do about getting boards made? Well, if we look down here, you're going to see that, obviously they have a little bit of a list of the services, and they got 2-layer boards, 4 and 6-layer boards, and they've got this one, this SMT assembly. Now I came across this. They launched this late last year, I think around August, September, and I took a look at this thinking, wow, I wonder could I get them to make some of my boards. And so I started in on the process back then, and it was not particularly friendly, and I guess I didn't either have the time or the patience or the bandwidth, or I wasn't in the right mindset to actually spend time looking at this thing. So what we're going to do now is I'm going to show you what I have done with the Prius board. And I'm going to show you that this SMT assembly service from JLC PCB is beginning to become what I think is going to be the best thing since sliced bread for me. Now, so first up, let's jump back onto Design Spark here, and we see this design And it's, you know, you can even see, even if we just zoom in a small bit, you can see that this is quite a it's quite a high density board. There's a lot of components, a lot of tracking. This is a 4-layer board. Red trace is our top layer, blue trace is bottom layer, and there are 2 internal layers. One is the ground plane and one is the 5 volts layer. Now, I'm not going to get into why I like 4-layer boards. I'll do that in another video if people want to know. But pretty much all of my designs, bar the simplest stuff, are 4-layer boards. Now, this design had 2 complete Hubner inverter systems, one to run MG1, one to run MG2. It had an Atmega 328 in here to run the DC-DC converter and the buck boost converter. I had even came over here and I had laid out the footprint for the Toyota Tyco connector that they use. Like, you can't buy it, so you were, you know, desoldering this off the original Toyota board and so on. It was doable. I did it. I got the prototypes, and surprisingly, for some weird reason, it actually worked. But I was really hit on BOM cost and lead times, and it's so many other projects going on that I just kind of had to shelve it. And I came back to it several times, looking at ways of, you know, converting a lot of it into Through-Hole and using the blue pill board and stuff like that, trying to make it more kind of home assembly friendly. And you know, I can say that in one way that was probably the wrong way to go for me. So over the Christmas, New Year, 2019, 2020, where we're just coming out of now, I sat down and I attempted to plug this design into the JLC PCB SMT assembly system here. And it was really like trying to fit a square peg into a round hole. But rather than giving up on that, I decided to see why. Why was I having these particular problems? And I did a deep dive into the whole JLC SMT assembly system, and I've now got it to a point that it's working for me. So what I'm going to do is I'm going to talk to you now about some of the things that I've had to do to get this to work for me. Now, I know that I'm going on, and I apologize, and people are tuning out, and there's funny cat videos to be watched. I know, I watched them too. But let's do something here, and I'll shoot to the very end of the process so that you're going to be able to see what happens. Then I'll backtrack and I'll show you how we actually got there. So we come into the JLC PCB page and we hit quote now, Gerber file. That's our new Prius board. We're going to drop it in there. Again, it picks it up. It doesn't pick up the 4 layers on it. We're going to select 10 boards. Then we're going to scroll down here to the SMT assembly option. We're going to turn that on. We want to assemble top side. All of my designs are single-sided surface mount. I don't put components on the back of the boards, which is going to turn out to be a good thing. We would like 10 of them. We will let the JLC PCB will put the tooling holes on the board for me, so I'll hit confirm. Now it's going to ask me for 2 files. It wants a BOM file and it wants a component placement file. So I'm going to throw those in, and don't worry, we will be back to show you how we got there. But where's my CPL gone? Where's my CPL? There it is. I'm going to throw that in. I'm going to throw in the BOM. We want BOM 1. There we go. We're going to hit next. Now it's selecting parts for me. Now sometimes this works straight out of the box, but because I'm recording this, it's probably not going to. And oh, it does. Yay. Okay, so that's picked up. Oh, there's only one part that it didn't pick up. I'll explain all this to you when we're going through it, and then we hit next. The next thing that it's going to do now is it's going to calculate the price, and it's going to give me this preview here. I'll deal with that later, but here's the thing that I want to show you guys here, and this is the one. Look at this bottom line here, total price, okay? What we're looking at now are 10 boards with all of the surface mount components placed. Now, they don't do true hole stuff, so we'll have true holers to go on there. But with all the surface mount components placed, 186 is the cost. It'll be about another 25 shipping. So let's call that 210. Then they'll hit me with VAT at this end. So let's call it 250 landed on my desk here for 10 PCBs with all of the surface mount parts placed. So a board is now 25 bucks, guys. Okay? And these will turn them around in about a week. And once I do this once and get it right once, it's rinse and repeat. Okay? So this is why I'm saying that I think that these guys, for us, are pretty much the greatest thing since sliced bread. And we're going to plug everything into this process, all of my PCBs. So not just this new Prius design, but we've got our Lexus controller, we've got our Nissan Leaf controller, we got our Tesla boards, and I'll probably make different videos again to deal with this. But just going to focus on the Prius stuff now today because this is going on a bit. So, how do we get to this point here where we have all of our components, you know, nicely lined up and we're basically ready to hit the order button here? Now, it's not, it is certainly not as simple as some of the sponsored videos would like to make out. Now, I guess what I should say is that the sponsored videos where they show you this tend to be these little simple little boards with maybe a dozen basic, you know, little SMD parts on them or something like this. They don't tend to be these super dense designs, at least none that I've seen. So if people have seen them, then please do leave me a link to them because I'd love to see them because I'm still doing stuff wrong here. Anyway, let's back up. Back to Design Spark. So I attempted to plug this design in there and it just would not work. Like, I would end up with maybe, you know, out of the hundreds of parts on this, I'd end up with maybe 10 or 20 placed and the rest of them would be just chucking errors all over the place. So what you've got to do is you've got to come back here. The easiest way to do it is just don't put in any files and click this what is JLC SMT assembly and come down here to this, and if you've got to have a look at this, guys, okay, because this is the critical bit. It's the bit that kind of the bit that you got to pay attention to. This is their component library. Okay, so we're going to click on that. That's going to bring us up the JLC PCB SMD parts library. Now, they will place any of the parts that they have. Okay, they will not order in parts for you. You cannot send them parts. You can only choose parts that are in the parts library. Okay. So obviously, I was coming along with my designs here, trying to plug them in with the parts that I'd chosen for my design, attempted to plug them in here, and it doesn't find them, and thus we can't place them, and thus I had previously thought, oh, this is a pile of crap, I'm just going to walk away from this thing. Now, I came along then, I looked at the Prius design, and I said, okay, what do we need this to do? Because there's been quite a bit of an evolution on the Prius stuff since I designed this PCB. People have been using the Prius Gen 3 inverter as a high power battery charger. Some people have made DC motor controllers out of them. Some people have used the DC-DC converters in them. So there's quite a bit going on. And I decided to take some of that feedback, and that's all on the Open Inverter forum, by the way, if you want to go there and have a look at it, and design a new board, which we will call the version 1B. Now, very quickly, version 1B here has got one Hubner inverter system for running MG2. It's got the Atmega 328 for controlling the DC-DC converter and the buck boost converter. It's got power supplies, digital analog inputs, connection to the current sensors, resolver, exciters. I'm not going to go through all this stuff here. If people want me to, I can do a much more deeper dive in it. But the point that I'm trying to show you here today is how we get from from having not any way to make these boards to now having it fairly straightforward that I can get these and more boards made. So basically, we can, with this design, we can drive the higher power stage. We can use MG1, which is the lower power stage, as a rectifier to take in three-phase mains power to make a high power battery charger. The booster converter here will let us control that power by, into a battery. We've got our DC-DC converter and everything else that we need to make things work. So you'll see here on the design, it's a little bit less busy. There's less components around here. And I guess the most important thing for people, I think, that I've done is I've deleted that Tyco unobtainium connector. We're using spring terminal, just 2.54 millimeter spring terminal stuff here, which is a lot easier to fit wires to. And, you know, I'll show you all this when we get the boards and we get them built. But how do we get them into the JLC system? All right, so going back to the library here, this is really the key to the whole thing. So if we type something in here into the library search and we go STM32F103 or BT6 and we press enter, it finds our microprocessor that is the heart of the Hubner inverter. And this guy here is in what they call the basic part category. Okay, so this is a basic part. They will charge them to me at €1.78 per part. Okay, now, so that's really good news that they've got them. They've got 10,000 of them in stock, so we're all good, right? Now, let's say I wanted to get another part, like the SAM3X8E, which is another micro controller that I use. Now, if we click on this, we'll see first of all that they've none in stock. But let's even say that they did. You will see that this is an extended part. What does that mean? So the difference between basic and extended parts means that the basic parts, these guys have always on the chip shooters, which are the machines that place the components on the PCB. If it's an extended part, it's not on the machine and has to be put on the machine. Okay, so what? Well, you can only have a maximum of 10 extended parts in your design. And this was the thing that I was absolutely banging my head against here for a few days. So if we go back here and we look at our Prius design here. So for example, you'll see that I have a little note here, 1 EXT, 0 EXT, 1 EXT. This is the number of extended parts. So I'm basically counting as I go. And I can only have 10 extended parts in my design. Now, that unfortunately is a total parts quantity, right? So the CAN transceiver that I like, which is this guy here, the SN65 HVD 234, is an extended part. If I happen to have a design that needed 10 or even 11 of these parts, that would be it. I can only have 10 parts. So then if I needed another extended part, like up here, say, where this one of these guys here, I think this switch mode controller is an extended part, I would be SOL, or sod out of luck, as they say. So what this means then is that you've got to come back and look at your design to minimize the number of extended parts. And I've been very lucky that I've been able to do that without, hopefully, any compromise in the design functionality. But we won't know that till I get a few in and I actually test them. Now, so now that we could wrap our design around having a maximum of 10 of these extended parts in there, that then says to us, okay, so I've got the design down to that point that I have a maximum of 10 extended parts. I think I have 9 on the Prius board. And that's fine. Next thing that we need to do is we need to create a bill of materials. Now, the bill of materials must be in the format that they specify. Now that format is that it's got to be in a CSV or Excel 97, which, you know, again, most of the programs can actually save to. I use this Open Office or whatever it's called thing here, and it works fine. They give you a little sample of that, and you've got to come along and have 4 columns. Comment has to have the value of the component, or we can put a lot of things in there. I tend to put the component values in. You've got the designators. You've got the package that they give you on the parts library, and you've got the part number that corresponds to that particular part. Now, one of the gotchas that I was coming up against was that it would only pick up some of the resistor values, despite the fact that I had the part numbers in and I was verifying the part numbers were correct and all this kind of thing. Turned out that what I really needed to do is, let's say in the case of these 1K resistors here, I used to just have 1K, that was it. But I really need to have 1K ohms with this omega symbol here. And once I put the omega symbol into the resistor values, everything was right in the world. So this is the format that your BOM has to be in, with a maximum of 10, be that, and that's 10 of any combination of the extended parts. It can be 10 separate parts, it can be 10 of the same part, it can be any combination thereof, but you've got to wrap your design around that. Now, the good news for us is that our designs are quite simple, so we can plug in there and we can substitute parts, like for example the inductor here and things like that. I've had to I mean, if we go in here and we put like 470 microhenries in there, which is the inductor that we use in the power supply section. It's this Sunlord part. I've never heard of them. But good news here then is when you need to get a footprint for these components, because that's half the work, is sometimes taking the data sheet and going and defining a footprint for it. You don't need to do that by hand anymore. You just literally grab the part number, and there's these guys. They're called ComponentSearchEngine.com. These guys are amazing. I've been using them now for years to get footprints made. So all you need to do is you just throw your part number in there, click search, and it will basically find the part for you. Now in the case here, this is one that I've asked them to make for me in the past, so they have made it. It's a completely free service. I don't know how they actually fund this thing, but I've really found this to be quite good. So if you need footprints for new parts and that, ComponentSearchEngine.com is the place to go for that. Not sponsored, I might add. So you get all your footprints made up and you plug them into your design here, and basically then once you get through all the little bugs, you end up where am I gone here? Oh, I'm gone all over the place. So basically then you just end up, it's pretty much rinse and repeat here. You throw in the plots, Gerbers. For some reason Design Spark calls them plots. I've never quite figured that out. Maybe they think I'm losing the plot, which I hate to tell them has already happened a long time ago. We basically throw in the BOM, JLC, throw in the CPL, hit that. It basically reads in the BOM, and you'll see here now, if we have a look here, it will always put the extended parts first. So we got 1, 2, 3, 4, 5, 6, 8, 9 extended parts in the design. That's perfectly fine. The rest of them are all basic parts, so I can have any amount of these things. I confirm that with them. I can go crazy. I can, literally plaster a board with these things. They don't care. For some reason, it doesn't pick up this particular crystal. I've tried everything with it. Maybe I've got something wrong here, but you just hit the search button, click basic. They've only got one 16 megahertz crystal under basic, so you just hit select. That's fine, it's a basic part. Click next, and we're pretty much back to where we were. It gives you this little preview thing of the placement. I spent ages trying to get everything right on this. Turns out that it doesn't really matter, because what they do is when you submit the design to them, so like you go through the cart and you actually pay for it, they come back to you with a preview, and they want you to verify that everything's correct on there. So that's it, guys. That is what we are doing with all of our PCB designs now. So I've sawed on for way long enough. Now, so once we get some of these boards back in, we get them physically in front of us, I will be back to you. And so yeah, that's it. That's what we're going to do. So we're going to be cranking away on the Prius stuff, Tesla stuff, and all new designs. I'm going to be able to plug the Nissan Leaf controller, the Lexus controller, and all this in here, and we'll be able to get them. We'll be able to get them a hell of a lot cheaper and hopefully more reliably. So that is about us. Alrighty, folks. I hope that you have enjoyed that. I know it's a bit of a long one. but I did want to get through as much detail in what we are doing here as we possibly could. So once we get some boards in, I will be back to you. We'll see what I've screwed up and not screwed up. We'll go through the quality and show you how to put on the bits that don't come in with them and la-di-da-di-da. So I'll leave you there. We will be back with some EV projects very soon. So until then, don't do anything too crazy. Do check out the links in the description for Patreon and PayPal in case you wish to financially support me with buying any more add-ons for my trusty Commodore 64. Also links in there for the Open Inverter forum and GitHub where you can download the designs and interact with people doing them and using them. So, lastly, do not forget to dislike, don't share and unsubscribe, and happy SMD PCB populating.